In this video, we're going to look at finding the reference angles on the Cartesian plane. So what is a reference angle? A reference angle is for any angle in standard form. It's the positive acute angle formed by the terminal side and the x-axis. So acute means that this is going to be some type of angle that's between 0 and 90 degrees. So the visual here's a Cartesian plane. We have our initial side from the x-axis going to the initial side. What the reference angle is the angle that's created underneath the initial side or the terminal side and the x-axis. So that would be considered the reference angle. So there are some subtractions that we're going to have to do to find this. So let's look at some examples to show you how you can come up with a reference angle. Here's one, 150 degrees. So essentially you're asking yourself the question, how many degrees away is this from the x-axis? Well, the x-axis is a completely straight line. There's 180 degrees on a line. So we will take our 180, subtract away 150. That's going to give us 30 degrees. So our reference angle for 150 is 30 degrees. Another example. Let's go 315 degrees. Again, we're looking for how many degrees away from the terminal side is the angle to the x-axis. Well, one trip around the circle is 360 degrees. Let's take the 360, subtract what we know from the 315. That's going to leave us with the remaining degree of 45 degrees. So our reference angle here is 45 degrees. A third example. Let's do negative angles. Well, whether we're doing negative angles or positive angles, we're still only concerned how far away is that degree measure from the x-axis. So we really don't have to worry about the negative sign on the 240. So let's drop the negative sign and let's subtract away the 180 to see how far away it is from the x-axis. So 240 minus 180 is 60 degrees. So again, our reference angle is 60 degrees for this angle measure. Can we do the same thing with radians? What if I have 5 pi over 3? Again, for right now, we don't really understand exactly where 5 pi 3 over 3 is located, but we can convert it back to a degree measure so we know exactly where it is. 5 pi over 3 is 300 degrees. Therefore, we can go ahead and plot it, and there is what 5 pi over 3 would look like. What a reference angle is asking us is what's the distance in degrees from the terminal side to the x-axis? Well, again, we're doing radians here, so that's taking 2 pi, because that's one trip around the circle. Let's subtract away our radians here. A good tip I would have for you on this is our answer is going to have a pi in it anyway, so we really don't have to worry about that if we're using our calculator. We can just type in what is 2 minus 5/3, convert it back to a fraction. That fraction is going to be 1/3, so we can say this is pi over 3. So our reference angle in radians this time is pi over 3. Let's try a couple more radian ones. 7 pi over 6. Again, not sure exactly what the degree or where that is located, but we convert it to a degree. That's 210 degrees. So visually, here's where 210 is, or 7 pi over 6. What's the distance in degree measure or radian measures from the terminal side to the x-axis? Now we're looking at a flat line, 180. 180 as a radian is pi. So let's take our bigger radian measurement and subtract away the pi. Again, talking about our calculator here, we have 7/6. Let's subtract away what's assumed to be a 1 there and not worry so much about the pi symbol. But if you do 7/6 minus 1, that is pi over 6, or 1/6. So our reference angle here, pi over 6. One last one. Let's do a negative radian. Sticking with our same method by converting it to a degree measure, negative 225. In the negative direction, here is where negative 225 degrees is. So in other words, that's where negative 5 pi over 4 is. Our reference then is how far away is it from the x-axis? That's 180, so we'll go with pi. So 5 pi over 4 minus pi leaves us with pi over 4. So there's our reference angle this time. So what's the purpose of reference angles here? Now think back in history. Mathematicians didn't have a calculator at their disposal to figure out what the sine, cosines, and tangents were for all these degree measures, but they had two really special right triangles that they could use. And those right triangles were our 30, 60, 90, and 45, 45, 90 triangles. And we had some relationship rules with those. Let's go through real quick and see what were the sines, the cosines, and the tangents for these particular triangles. Let's start with the 45, 45, 90. Well, sine, that's the opposite over the hypotenuse, which would be x over x root 2. But what you'll see here is that the x's are just going to cancel each other out, and you're left with the ratio of 1 over root 2. Rationalizing this will give us square root of 2 over 2. Let's try the cosine. The cosine of 45 degrees. This one is adjacent over the hypotenuse. So again, we have another x over x root 2. So going through the whole rationalization process, we have another square root of 2 over 2. And then finally, the tangent of 45 degrees, opposite over the adjacent. That is x over x, and anything over itself is simply 1. So the tangent at 45 is always going to be 1. The cosine of 45 and the sine of 45 is square root of 2 over 2. Moving over to the 30, 60, 90 triangle. Let's start with 30 degrees. So the sine at 30 degrees is opposite over hypotenuse. Writing our ratio there, we end up with x over 2x. The x's cancel out. That leaves us with the ratio of 1/2. The cosine at 30 degrees, now we're looking at adjacent over the hypotenuse. So that gives us x root 3 over 2x. Again, the x's cancel out. So we have square root of 3 over 2. And then the tangent of 30 degrees, so the opposite over the adjacent, x over x root 3. The x's do cancel out again, so 1 over root 3. Rationalizing that fraction gives us square root of 3 over 3. Let's do the same thing for the 60 degree measure now. So the sine of 60, now we're down the bottom angle here. That still is opposite over the hypotenuse. The opposite this time is x root 3 and 2x. That cancels out, and we've already completed this with the cosine of 30 degrees. And moving on to the cosine of 60, we have x over 2x because we have adjacent over hypotenuse. And then the tangent, we have the opposite over the adjacent. So you'll see that these all simplify back down to root 3 over 2, 1/2, and square root of 3 this time. So let's see the connection here. We're going to find our reference angle, go back and see where is our sine of these angles, cosines, or the tangents. And then the last thing is, where is the original angle located at to know whether we need to tack on a negative sign or keep it positive. All right, some examples. So the sine of 120. Well, what would be the reference angle of 120? Well, that's going to take 180 minus 120, giving us 60. We're going to refer back to 60 degrees up in our little diagram that we have above here. Now, what is the sine of 60 degrees? Well, we find it. The sine of 60 degrees is the square root of 3 over 2. Next, the original angle, 120 degrees, is located in the quadrant where sine is positive. We're in the second quadrant. All sines are positive in the second quadrant. If you think back to our little acronym that we had, all students take calc, sine is always positive in the second quadrant. So we get to leave the square root of 3 over 2 positive. So what would the sine of 120 be? It's positive root 3 over 2. How about the secant of 225 degrees? Well, if you remember that secant is the reciprocal function of cosine, we can work this problem out using the cosine of 225 degrees. But still, we need to figure out what is its reference angle. 225 minus 180 degrees, that gives us a reference of 45 degrees. So we go back up in here and to ask ourselves, what would be the cosine of 45 degrees? That's square root of 2 over 2. So we'll start with that. Next, we know that the 225 degree measure is in quadrant 3. That leaves us to know that cosine is always negative. Again, thinking back to all students take calc, the only thing positive in the third quadrant is tangent. So now we got to tack on a negative sign to our root 2 over 2. Finally, going all the way back to secant. Secant is the reciprocal of cosine. So we flip our fraction, rationalize our fraction, which gives us negative 2 root 2 over 2. And then finally, the 2 on the top from the negative 2 and the 2 on the bottom cancel out. The secant of 225 degrees is negative square root of 2 over 2. Okay, the last one we're going to look at is with a radian measure. What would be the degree measure for 11 pi over 6? Go through our conversion of 180 over pi. That gives us the degree measure of 330 degrees. So then we can go in and find our reference angle. The reference angle here, since we're in the fourth quadrant, we're going to take 360 minus 330. That would be 30 degrees as our reference. And go back up and look at our ratios here. What was our tangent at 30 degrees? Well, the tangent is square root of 3 over 3. We're going to use that ratio here. So we know that for sure. Second, 11 pi over 6, or in other words 330 degrees, is located in the fourth quadrant. And that's where tangent is negative, because tangent is only positive in the first and the third quadrants. So since we're in the fourth quadrant, we tack on a negative sign to this. The tangent of 11 pi over 6 is going to be negative root 3 over 3. So there's how you can use reference angles to figure out the trig values at any given measure, whether it's degree or a radian.